thank you for showing up at 9:30. I know it's the first spot in the schedule, but it means you're motivated. That's good to see. This talk will be about Git, and in particular about surviving with Git. So undoing and recovering from mistakes. And I feel I have to answer two questions first. The first one is, why the hell am I talking about Git? This is the easy answer for me because I am the CEO and founder of Tower. Tower is a Git desktop client for the Mac and for Windows. And we've been on the market for almost 8 years and have worked with some good customers over the time, over 100,000 by now. But the good news is this is not going to be a talk about Tower. You will see Tower in one or two occasions, but it's a talk about Git, and I will do a lot of things on the command line for you, so you will see me typing a lot. The other question is, why about undoing things with Git? In talking with our users and everybody who's using Git, we often hear that undoing things, breaking things, and recovering from mistakes is, of course, a big topic for everybody. And it helped me a lot to know what I can do to undo things or mistakes. You have a safety net with Git in your hands, and I think it's great to know how to use it. I mean, that's the reason why Git is there, actually. Okay. And it's interesting to see, I'm doing these Git talks since quite a while now, and I've talked to 2 people in the audience, 100 people in the audience, so Git seems to be a very volatile topic. That's interesting to see. So. Good, let's start with the first scenario, or the first type of things that can go wrong, and that is undoing local changes. So changes that haven't been committed to the repository yet. Okay, let's go. So let's pretend this would be a very easy web project, and we have a couple of changed files here, 2 modifications, 4 modifications, and 2 deletions. So let's look at one file in particular and see, yes, this looks like a stupid change, so I want to undo this. And undoing something like that is pretty easy. You can use, I'll go at the top, you can use the git checkout command for this and tell it to which repository, to which revision you want to return. It's a head revision in our case, and on which file you want to work. So you know git checkout from switching branches. This is quite a versatile command, and in this case it undoes your local changes in that file. And to prove that, we can again git diff about HTML, there's nothing there. We can git status, and we'll see it's not amongst the changed files anymore. So this is the first and probably easiest case. And the good thing about git checkout is it also works with deleted files. So we have deleted error HTML in this case, and if I want to restore it, I can just use git checkout, and it's not amongst the changed files anymore, and it will appear here in our working copy again. So this works for local changes no matter what you did, if you changed something or even deleted a file. Next level of granularity, let's say. And indeed, I need a graphical user interface because I don't know the commands for that. So excuse me. Probably hard to see from the back. As I said, let's go one level more granular in this case. So this is changes in a file in index.html, and we have two chunks, two areas we've modified. And in Git, we can also say, just discard this whole chunk. So undo the changes in this chunk. Voila. As we started out. And we can even go, and I find that really, really helpful. I can even say, discard the changes in those two lines. So this is really, if you have a long file and have worked on it for a couple of days and a lot of modifications, and you say, well, I want to return these parts of the file to its original state. You can just do that too. So everything is possible when it comes to undoing things. Undoing the whole changes in the complete file, undoing a deletion, or even undoing individual lines in a file. And stepping all the way back in granularity, if you want to undo everything you did since you last committed, this is the git reset command with the hard option. And again, to which revision do you want to return? To the head revision, to the last committed revision. And this, well, this is the big gun. You just erased everything that you did that was not committed. So, a little wrap up for this first part for undoing local changes. You use git checkout, the revision and the file name to undo things in individual files. And you use git reset hard to undo everything. A little warning message here. Discarding uncommitted local changes cannot be undone. This is the one thing I would say you cannot undo in Git. You can't undo undoing local changes because they have never been committed to the repository. They've never been in Git's database, let's say like that. So you can't undo that. So be sure when you do that, and that's everything. Okay, so scenario number 1, undoing local changes. Scenario number 2, undoing committed changes. So when you have committed bad stuff. One very, very easy case is you had a typo in your last commit message or forgot to add a file. So this is one very common case. It's easy to mistype a commit message or to forget something to include. Again, work for me. Okay, so I'll show you where we are. I'll show you the history here. So I have this terribly mistyped commit message right there, and I want to correct it. I'm lucky because it's the very last commit, so I can very easily change that. And this would be just like a normal commit, but with the amend flag. Amend tells Git to modify, to actually replace the very last commit. And I can finally correct my bad typo. Typos are indeed embarrassing. It's very embarrassing if you mistype embarrassing. No, that's right. And you will see, if I go back here, wait a second. Yeah. Do we have a real problem? So it looks like nothing has happened. It looks like I have never did that terrible typing mistake because Git replaced that very last commit with the amend flag. So, and the next problem I could fix is Git status. It seems like I forgot to add this modification here in index.html. I forgot to add it to that commit. And I can easily just git add, like I would with a normal commit, let's say. And then again use the commit command. Do you see that in the back? No. Sorry. The git commit command, again with amend. And in my case, I even say no edit. No edit means I don't want to change the commit message this time. So I just want to add what I just added with the git add command, and that's it. And amend says, please correct my last commit. So I just added index. Git log p. Okay, here it is. I just had a look at the git log and see that index is now included in this very last commit. So fixing the very last commit is easy with the amend flag with git commit. Good. I should actually. That's what you get when you work with development versions of your own software, because I want to see that in Tower 2. Okay, here we go. So the index change that we just added after the fact, let's say, is now also part of this very commit. And if I say this very commit, I'm wrong, because Git really replaced that last commit. This is not the same commit object as it was before I tried to deal with it with git amend. Yeah. You should be able to. I don't know if it does with git commit amend. This is the easiest tool. That's why I'm showing you it, because it works on the last commit. But actually, you're replacing the commit. So I think you should also be able to correct the author. The commit has changed, and that's the important thing to keep in mind. Even twice, actually, because I used amend 2 times. One when I corrected the commit message, and 2 when I added a file. So we have a brand new commit object here. So the one thing to keep in mind when you're using amend is don't use it on things you've already pushed, because your colleagues will hate you because they have already that data and you're pushing the same commit again. So use that on your local commits to clean up. And this is I think you won't fall into this trap, because the use case for this is, oh my god, I just made a terrible typing mistake, or I forgot that one file. It's rare that someone mistypes, forgets to add something, and immediately pushes it to the remote repository. But keep in mind, don't do this on commits that have been shared already. That's the one reason, or the one rule to keep in mind. Okay. Amend. Another scenario, a different type of problem, reverting a commit. So the scenario here is this commit was bad. We want to undo this commit here in the middle. Everything that came afterwards, C3, is perfectly fine. We just have a problem somewhere in our commit history, somewhere in the middle. And this is a case for git revert. And the great thing about git revert is Git does it all for us. It's totally automatic. So when I say, I'll do that in practice right now, when I say revert this commit here, please, Git automatically adds a new commit. This is the correcting commit, let's say, with changes that, well, revert the effects. So if I change this line from this to this, Git is clever enough to change it backwards on its own in a new commit. So actually, and this is also quite a good rule to keep in mind, Git rarely deletes stuff. So it doesn't go and delete C2 and add something new. It almost always adds data, and that's good to know. So again, it's very hard to break things with Git. It's always there somewhere. You have to know where to look or which tool to use. So as said, this is quite easy. Let's pick someone. Yeah, let's pick this one. And you'll see in this commit I changed about into about this project. That's the whole change. And let's say I want to undo this. And I can just say git revert and the commit hash that I want to revert. And that's actually it. I'm asked to enter a commit message. I'll go with the standard one that Git proposes, and that's it. And here we go. We have, as promised, a new commit in the history. So nothing deleted, nothing removed. And if we look here, Git automatically changed about this project back into about. So this is all automatically done for us. You'll know. Git will show you. Git will let you know. Yes, you will have local changes, and Git will tell you, hey, there is something you have to care for, you have to look at, and then you can probably commit after solving that conflict. No, but the question was if you can revert parts of a commit. Well, yes and no. You can add a flag when reverting that you don't want it automatically committed. So Git will just create local changes for you in your working copy, and you can decide, well, I want to undo this and that, and revert that, and discard that. So you're quite flexible with that. Yes?
I guess I did not get it correctly. So when I, for example, from history, I committed 10 and I want to revert to 5. What happens with the changes from 6, 7, 8, 9?
That's a different part. It's good that you ask. That's a different scenario and a different command, which we will show now. But reverting is really only picking one bad guy or two bad guys in the middle. You leave the rest of the history untouched and you don't want to change anything because everything that came afterwards is fine in this case. If we're talking about that case, you see, well, you had a bad day and produced, well, not optimal changes after C2. Probably had too many coffee. You want to return to C2 and forget everything that came afterwards. That's the other case. So, and that's a different tool, a different command. That is what git reset is for. So you really have to, the difficult part in undoing things in Git or in any system is understanding your scenario, understanding the problem, what's the problem, and finding the right tool or picking the right tool. That's actually the job to do, because what I show you is not difficult. You just have to know and remember and understand what scenario you're in. So this here is really rolling back is a synonym for git reset. So you roll back your complete history to one point in time and forget about everything that came afterwards. Well, that is, yeah. Yeah, that is actually the revert case. So there's also, in both cases, 4 commits in the example. So if you have that, if C1 is bad or C2 is bad, but everything else is okay, you go with git revert. But if you really want to return to some point in time and forget everything afterwards, that is reset. So you can do both, but you have to decide, do I want to reset or revert? Good, so let's do that. And let's return to this beautiful fella. So I want to return to add simple robots.txt and forget everything that came afterwards. And as promised, that's not rocket science. Git reset hard, and the commit hash I want to return to. And let's see what happened. Yep. So I have to be careful how I say it. It appears that the commits afterwards are deleted. They're not there anymore. Let's say it like that. So we got what we wanted. We return to a previous point in time, let's say, with the reset command. So as a little summary for the second type of mistakes for committed things, you have three big tools, I would say. The commit amend command, which is only useful for the very last commit and only if it's not pushed yet. That's the thing in parentheses. Git revert if you have one or two commits in the middle that you want to undo, but leave the rest that came afterwards untouched. And git reset hard to really go back in time and to roll back the complete project back. Good. Yes, please. If you haven't pushed. Yeah. Use git amend, delete the remote branch that nobody uses except for you, and recreate the remote branch. That's perfect. It's yeah, absolutely. Yeah. Yes, exactly. Because you would have the same commit twice or three times in that case. So yeah. But locally, that's really a tool to clean up locally, actually. Yeah. Yeah. Well, not really. So you'd at least have to consult your colleagues if they based their work on, you just took away some commits from them, right? So if they based their work on these new commits, you'll have to talk a little bit and find a solution. Yeah. Okay. So next type of problem, which is directly related to what we just did. You think you want to reset and roll back in time. You do that reset, and you notice it was a bad idea. So step 4, you panic, yeah. And as I said, you can really undo the undoing of undoing things in Git. You can undo everything, and even that. So when I showed you reset, I was careful to say it appears that these commits are deleted. They are not deleted. Rest assured, everything is still there. Garbage collection in Git kicks in after 30 days, I think, if nothing is referencing a commit, so you have plenty of time to fix up even your bad fix-ups. So no problem. So let's look at this scenario here. And the tool in our tool set is Git RefLog. So the RefLog is think of it as a journal where Git protocols all the important stuff. The important stuff is the things that happened with the head pointer in Git. So checkouts, branch switches, merges, rebases, all of the important things are protocoled, are journaled here. So everything is there for us if we have a problem, and we seem to do. Yeah, let's see how we can undo what we just did. So our scenario is this at the moment. We resetted to a couple of commits before, and let's say we want to undo that because we noticed it was a bad idea. Git reflog is the command that shows us what has been going on, and you can read it from the top, so the newest items are on the top, and we see, yeah, there was a reset, we moved to 0023C and that was the bad thing. So let's return to one step before. And that's easy because you know the commands already. It is, again, git reset. And voila, we're back in the game. Nobody noticed that we broke everything, and we are where we left off before. So the RefLog is it's a really powerful tool because it protocols these very important points in time. And but there's everything there. So this is your last insurance. Everything is still there. New version of Tower also supports the RefLog, but it's too easy on the command line. So if you know, go ahead. Good. Well, just to say that once, or to show you an alternative, I'll reset here. Just as an alternative to do that, you could also go and git branch happy ending. So what I'm doing here is I create a new branch based on that old commit that I just deleted with the reset. This leaves you just a little more options. So I guess you had a reason why you did that git reset on master, I suppose. So it's probably that you want to look something up, you deleted something that you want to have a second look at, and by creating a temporary branch, you can do just that. So you have a lot of options how to restore things. You don't have to reset on master. You can create a new branch, have a look, and delete that branch again. Just to show you another option how to deal with that. And delete that. Yeah, it's not fully merged. Good. Okay. We are not running out of things that can go wrong. This is the next type of thing that can go wrong. You commit on the wrong branch. That is very popular. So you should have created a new branch, actually. But hey, git commit is very quick. So you committed on master, probably, which many teams don't like. And you actually should have done that. So you started developing a new feature, let's say the login feature, and this should be on a separate new branch. Right? So let's correct that. Okay, yeah. So we have the problem scenario already at hand. You see a start new login feature commit right at the top, and it's on master. This smells. So let's correct that, and let's get a new branch, a separate branch for that. So the way to do that is to create a new branch. Let's say, what was it? Feature login, I guess, yeah. And this new branch is where we left off. So this looks right. Start new login feature on the feature login branch. That looks good. And it's the same tools you already know. We just reset. We just reset the master branch to that one commit before. To that one commit before. And have what we wanted to have, a clean new feature branch, and most importantly, a clean master branch. So, yeah, please.
What if you wanted to have that feature in the development branch, which is existing?
Let's look at that in a minute, yeah. Because this is as if you knew my slides, the next problem we're facing. So when it should have been on a different branch that already existed. So the login branch is already there. So why do we have that thing on master? That's a slightly different problem and requires a slightly different angle. So this is what we want to have, actually. So let's produce some changes. Sign up HTML. Let's add that and commit it. Sign up for a newsletter. Sign up for a newsletter. Ah. Well, we'd have to simply rename it and commit it again. So, is that okay for everybody? Okay, so we have this commit and master, and it shouldn't have been on a new branch. It should have been on an existing branch. Sign up for a newsletter sounds like the newsletter branch. And what we can do is simply cherry pick. Cherry pick is, you can pick, in the end, any particular commit and put it on another branch, let's say like that. And the command for that, so we now have that commit on the newsletter branch. That's what we want. On the command line, it's git cherry pick and the commit hash. And again, what we have to do is clean up the master branch. Again, with the git reset, and always be careful to take care that the right branch is checked out, that you're working on the right head branch. That's the only thing to look for in these situations. But again, we have a clean situation. The master branch doesn't have that unwanted commit anymore, and it's where it belongs, in the feature newsletter branch. Creating new branches, git cherry pick, git reset. These were the commands for these types of problems. Good. This is not a real problem, but it's a question that often comes up, or yeah, a question. And so the question in detail is, I have produced a couple of changes, maybe merged local stuff, and am wondering, what exactly am I going to push right now? Because I've worked for a couple of days and done crazy things. And this is where the git log command, the git log command is incredibly versatile. So there are parameters and flags all over the place. You just have to know the ones you need. And the not flag is quite helpful in this case. So let's look at that. Let's look at the general situation here. So with the git branch command, I get an overview of what branches I have, and currently I have the master branch, and I already get a basic information about what will happen if I push now, because the branch command tells me the local master branch is connected, is tracking the remote origin master branch, and we're ahead 2. So ahead 2 means we have 2 local branches that are not on the remote yet. So that's our first information. We know we would push 2 commits, but what exactly would be pushing? And this is where a little bit more information is nice. And let's use this not flag for log. And you say, okay, so these 2 commits are on master, on the local master branch, but not on the remote one. So this is exactly what I would be pushing. Could be helpful in some cases. In graphical user interfaces like Tower, you have the same information mostly next to a branch. So this is the equivalent of git branch dash VV. So you know 2 commits are local and not remote yet. And you see those little arrow icons here and know exactly these 2 commits will be pushed on the next push. And the same on the command line and in tower reverse if something hasn't been pulled yet. So if you don't have data that is already on the remote, the arrow points downwards. Or you are behind on the command line. Ahead means you have local commits that haven't been pushed. Behind means the other way around. Okay, and one last half problem. Nothing broken, but still something that is rather interesting. The Git large file storage system, well, it's relatively new, I would say, 1.5 years, I think, in broader public. The problem with versioning binary files, big binary files, is a natural one. Your local repository, or your repository in general, will grow, 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 and grow, incredibly grow. So if your designer chooses to check in Photoshop files or movie files, which is totally okay. So if you're working in a mixed team, or if you have an asset repository or something like that, that's good. Put binary files in version control because they want to be version controlled. But what is not good is if he changes a pixel in that 100 megabyte Photoshop file, it's another 100 megabyte Photoshop file that has to be versioned. So you quickly get quite big repositories without Git LFS, and that's not a good thing. Especially for people that want to start with that project and have to clone it because they have to wait for ages and a lot of crap on their hard drive. So let's look for a different type to do this. So what LFS does, LFS is a Git extension that you can install. Git LFS introduces 2 new things. One, an LFS cache on your local machine or in your local Git repository, and an LFS store on the remote end. So your remote hosting provider has to support that. I don't think anybody doesn't. So GitHub does it, GitLab does it, Bitbucket does it, Beanstalk does. So Git LFS is quite well supported these days. And the thing is, do I have that here? No. The thing is, the great thing is, you only have the data that you need locally. That's the big change. You don't have all of the data that has been produced over time. So if you have 10 versions of that huge movie, audio, Photoshop file, then you will only have the version you need. Need is a little bit flexible said, but Git LFS knows what revisions you need and checks them out for you. So by default, locally you only have tiny, tiny pointers to those huge files. And when you need those files, when you really need them, when you check out a revision with that huge file, Git LFS notices and gets you the data you need on demand. And that's the big change. So, of course, your remote repository and the LFS store remotely will grow with growing data. That's okay, you can't avoid that. But your local repository is lean and only contains the stuff you need. That's the big change. Good. So pointers instead of real data is the solution here. And it's too easy to actually show. Install it, and then you can tell Git LFS to track certain files or certain types of files. So please watch all movie files and take care of them with LFS. Good. So, 2 little announcements. One is, if you want to learn more about Git, not only Tower, mostly about really Git, then go to our Learn page, gittower.com/learn. There's free ebooks, a video course, cheat sheets, everything. And as I said, most stuff is really for Git and not only for Tower. So enjoy. And lastly, if you want to try Tower for Mac or Windows, this is a good point in time because we have a public beta for a new version, and it's free at the moment. So if you want to try it out, go to Git or Google Tower Beta. That's better because the URL is a different one, and try it for free. That's the only advertisement I dare to bring here. Good. That's it from my side. Questions, remarks, anything? Not really, I would say. There is subtree, and it's a religious fight between those who like subtrees and those who like submodules. But I would say that submodules have won that religious war somehow. They are more popular and more widely used. And I just have to say, yes, they're a pain in the ass to manage. And honestly, I couldn't do it without Tower because the configuration is spread over 3 different files. It's in Git modules, in Git/modules, it's in the Git modules file, it's somewhere else. It's really a pain, so I wouldn't touch it without a graphical user interface. I'm sorry. It's just not easier. Yeah. There's those little things. I mean, when you check out a different branch and you have different submodules, different revisions in these branches of a submodule. Git by default doesn't fix that for you. So you have to remind yourself, oh, I just switched the branch and I have to update the submodule. Come on. That's not good. Oh, well. Yes, it does. Yeah. Good. Thank you very much for your attention and have a great conference.